Assalamualaikum and a very good day to all. So welcome to Managerial Economics lecture. This is the third lecture in the series. So basically today our main aim is to look at chapter 3, okay, which is actually on demand analysis, okay. So in managerial economics, demand is one of the most important aspect, okay. It is very essential to understand demand because it ensures success in the creation, survival, and also profitability of a company. In this chapter, what we are trying to do is to understand demand. Okay, so we're going to look at what are the factors that influencing it, how does a demand function looks at like, okay, and also looking at the concept of elasticities, where we are trying to understand how responsive is demand to change in factors that influencing it. Okay, so by having understanding on demand and we know how to manage it, okay, so hopefully we are able, okay, to manage, okay, a company effectively. Okay, all right, so let us start by looking at what actually demand is. Okay, so when we talk about demand, okay, bear in mind that it is the quantity of goods and services, okay, that customers are willing and able to purchase. Okay, so when we talk about demand, we always refers to buyers. Okay, so these are what constitute demand. Okay, now there is one important theory, okay, in demand that tries to relate, okay, price and quantity demanded. Okay, so we call it as law of demand. So basically what the law of demand says is that there is always an inverse or negative relationship between price and quantity demanded, ceteris paribus. That means holding other factors as constant. So if you are only focusing on price and quantity demanded for a product, holding other factors constant, you're going to see there is always a negative relationship between price and quantity demanded. So, well, that makes sense, isn't it? So you as a buyer, when price of a product is very high, definitely you're going to demand it much lower quantity of that product. But when price falls, you would want to buy more of that particular product because now it's cheaper. Okay, so that's the law of demand. All right, so if you want to sketch the demand curve, okay, so normally, okay, what we're going to have is on the vertical axis we're going to have price, and on the horizontal axis we're going to have quantity demanded, and your demand curve will always be a downward sloping curve to reflect the fact that there is a negative relationship between price and quantity demanded. Okay, now notice that when we draw this demand curve, we are only focusing on price and quantity demanded, meaning that the only factors that we look at would be price of the product itself. Okay, but in the real world, okay, there are many factors that influence demand apart from price of the product. So this brings us to the third subtopic, that would be determinants of demand. So when we talk about determinants of demand, this actually refers to the factors that influence demand for a product. So apart from price of the product, okay, there are also other factors. For example, price of related products, income of consumers. We can talk about advertising expenditure, okay, the expectation about future price, and so many other things. So there are so many factors that influence demand. Okay, now to show the relationship between quantity demanded and all other factors that influencing it, okay, so we need to look at a demand function. Okay, so a demand function is simply a mathematical function. Okay, it shows the relationship between quantity demanded, okay, which is always your dependent variable, and all the determinants of demand, which are your independent variable. And as I said to you just now, okay, so these determinants can be in the form of price of the product itself, it can be advertising, income level, taste of consumers, and many other factors. Okay, so now what we would like to do is we're going to look at the different types of demand function. Okay, so there are two different types of demand function that we're going to deal with. Okay, so one is what we call as a linear function, the second one is a multiplicative function. Now, the general format of a linear demand function would be as shown on this slide. Okay, so as you can see, you have the quantity demanded for product X, okay, as the dependent variable, and all the other factors that influencing it will be on the right hand side of the equation, because these are all independent variable. And if we look at the type of this function, you have a constant which is represented by A, and you also have coefficients, okay, which is represented by the B's. So in a linear function, okay, the constant A actually indicates the amount of quantity demanded if all the factors influencing it are equals to 0. Okay, but when we talk about these coefficients, okay, the B's, okay, so it will tell you about the marginal impact of each independent variable on the quantity demanded. So in other words, okay, the B's will tell you how much quantity demanded will change when the factor influencing it changes. So for example, in this case, assuming that the value of B is 5, okay, so meaning that when you change, okay, price of good X by 1 unit, so quantity demanded for good X will change by 5 units. Okay, so another example would be if, let's say, the coefficient for B2 is 10. So this simply means if you change price of another good, which is Y, by 1 unit, then quantity demanded for good X will change by 10 units. Okay, so that's what the coefficient in a linear function tells you. Okay, now let us proceed with the multiplicative function, which is another form of the demand function. Okay, now in a multiplicative function, the exponents, so in this case the B's, okay, measures the percentage change in the dependent variable when you change the independent variable by 1%. So if, let's say, the value of B1 here is equals to 5. So this simply means, okay, when price, okay, of good X changed by 1%, quantity demanded for good X will change by 5%. So this is how you interpret the exponent in a multiplicative function. So the way you interpret the value of B's in a linear function and in a multiplicative function differs. Okay, so in a linear function, the B's, okay, simply refers to the change in the quantity demanded when you change your independent variable by 1 unit. Okay, but in a multiplicative function, the B's or the exponent actually represent the percentage change in quantity demanded when you change the respective independent variable by 1%. So in a linear function, okay, the B's represent a unit change, but in a multiplicative function, the B's represent percentage change. Okay, so that's the difference between the two. Now, in this course, we're going to deal a lot with the linear function. Okay, so that will be the type of functions that we're going to deal a lot of. Okay, all right. Now, so by now, okay, so you should have an idea of what demand actually is. Okay, what are the factors that influencing in, and how we can represent, okay, the demand function, okay, which are of two forms, the linear and the multiplicative function. All right, now the next thing that we're going to do is to learn how to derive to the demand curve function. Okay, so when we talk about demand curve function, it is simply an equation that shows the relationship between price of a product and quantity of that particular product. Okay, so there is a difference. Okay, so bear in mind that a demand function is the long function. Okay, so it shows the relationship between quantity demanded and all the factors that influencing it. But when we talk about demand curve function, this is a function that shows the relationship between quantity demanded and its own price. Okay, all the other factors that influencing it are held constant. All right, so the general form, okay, of a demand function would be, okay, Qx equals to A minus B1 Px. Okay, so you can see that it only shows the relationship between quantity demanded for X and price of good X. So what will happen to the other variables? Well, the other variables are held constant. Okay, now from your demand curve function, you can derive to your price function, okay, which we also call it as the conventional demand curve function. Okay, so if you want to derive to the price function, what you need to do is you need to rearrange this equation. Okay, so what happened is that, okay, we're going to bring price to the left hand side of the equation and quantity to the right hand side of the equation. So we're going to switch row. Okay, so now what happened is that when you bring negative B1 Px to the left hand side, you're going to have positive B1 Px, okay, equals to A, and Qx here, which originally is at the left hand side of the equation, we're going to bring it to the right hand side of the equation and it will become negative Qx. Alright, so now remember, we only want price function, so you have to divide both sides of the equation by B1. So you end up getting Px equals to A over B1 minus Qx over B1. So this is what we call as your price function, or also known as the conventional demand curve function. Okay, now let's look at an example here. Okay, so you are given a demand function. Okay, you can see that it is Qx equals to 2 minus 3Px plus 2i plus 3Py plus T, where Qx represent quantity demanded for good X, okay, Px is price for good X, I represent income, Py represent price of good Y, which is another product, and T represent this. Okay, so here you are also given the values, okay, for all your variables. Okay, now what we're going to do is, from this long demand function, we're going to derive to a demand curve function, meaning that we want to reduce the demand function into a demand curve function which only shows the relationship between quantity demanded and price. So how are we going to do that? Well, what you need to do is, okay, you need to take this long demand function and you're going to substitute the values, okay, for all the independent variable except for the price of good X. Okay, so as you can see here, it's given that income is equals to 4, so you're going to replace I by 4. Okay, price of good Y is 3, so you're going to replace that with 3, and taste is given as 1, so you're going to substitute T equals to 1. Okay, but just leave price for good X as it is. Okay, so when you simplify this equation, you're going to end up getting Qx equals to 20 minus 3Px. So this shorter function is what we call as demand curve function, which only shows the relationship between quantity demanded and price of that particular product. Okay, now you can also rearrange this equation, okay, if you prefer to have price as the dependent variable. So all you need to do is simply rearrange this equation. So we're going to bring negative 3Px to the left hand side of the equation, so it will become 3Px. Okay, Now, QX, you're going to bring it to the other side and it will become negative QX. Okay, so what we're going to do, we're going to divide both sides by 3. So you're going to end up getting PX equals to 20 over 3 minus QX over 3. So this is what we call as price function or conventional demand curve function. Okay. Alright. The next thing that we're going to do is we're going to look at the relationship among total revenue, average revenue, and marginal revenue. Okay. Now, I have already explained to you that a demand function only shows the relationship between quantity demanded and price. Okay, and the conventional demand curve function is also a demand function. It's just that price is the dependent variable and quantity now becomes the independent variable. Now, from this price function, you can further derive to 3 revenue functions, namely total revenue, average revenue, and marginal revenue. Okay, now total revenue simply represent sales. Okay, now if you want to construct the total revenue function, what you need to do is you need to first of all have the price function or the conventional demand curve function. So given the conventional demand curve function, okay, now your total revenue is P times Q. Okay, that's the general formula for sales. So if you want to derive to total revenue function, always remember you have to replace or you need to write P function in the form of conventional function. Okay, so you need to substitute P in the form of a function. So we know that the general format of a P function is A over B minus 1 over BQ. And then you have to multiply by Q. So when you cross multiply, you're going to end up getting A over BQ minus 1 over BQ squared as your total revenue function. Okay. Now let's move on to average revenue. Okay. Average revenue is the total revenue generated by one output. Okay. Or you can calculate it by dividing total revenue by quantity. Okay, because when we talk about averages, you always need to divide total by quantity. So if you want to measure average revenue, you have to divide total revenue by output. Okay, so and as you know, average revenue is P times Q. Okay, so you divided it by Q. Now Q and Q, you can cancel it off. So you're going to end up getting average revenue equals to price. So the thing is, average revenue and price is the same thing. And for that reason, the equation for your average revenue is going to be exactly the same as your price function. Okay? Now, the last revenue concept is marginal revenue. Okay? So marginal revenue actually tells you how much revenue change when you change output by 1 unit. Okay? So when we talk about marginal, okay, so we can also use the concept of differentiation. So in deriving to the marginal revenue function, you have to differentiate total revenue function with respect to Q. So remember, this is your total revenue function and we want to differentiate it. So if you differentiate A over BQ, remember you have to use the line rules. So you're going to get A over B, and differentiating negative 1 over BQ squared requires you to use the power function rule, and that will give you negative 2 over BQ. So your marginal revenue function is A over B minus 2 over BQ. Now notice that when you compare the 3 equations, you can see that the total revenue function, the highest exponent is equals to 2. So meaning that total revenue function is a quadratic function. Okay, but the rest of the function, average revenue and marginal revenue, is a straight line function. Okay, because the highest exponent for Q is equals to 1. Now another thing that I would like to highlight here is that the slope of your average revenue function and marginal revenue function. The slope for average revenue function is negative 1 over b, but the slope for marginal revenue function is negative 2 over b. So this means that the slope of marginal revenue is twice the slope of average revenue. So this simply shows that your marginal revenue function should be steeper than average revenue. Okay. Now, let's look at an example of how you derive to a total revenue function and marginal revenue function. Okay. Now, if let's say you are given a price function which is 6.5 minus 0.5q. Okay. Let's say you want to know what's the total revenue function. So total revenue, the basic formula is P times Q. And as I mentioned to you just now, to derive to total revenue function, always write the P function in the form of a function. Okay, always represent P as a function. So you are already given P equals to 6.5 minus 0.5Q. So substitute that into your total revenue function. So you're going to end up getting total revenue function equals to 6.5Q minus 0.5Q squared. Okay. Now we're going to proceed with marginal revenue. Now the formula for marginal revenue is already given as the derivative of dr with respect to q. So if your total revenue is 6.5q minus 0.5q squared, so your marginal revenue function is going to be 6.5 minus q. Okay, so remember, if you differentiate 6.5q, you need to use the line function, and if you differentiate a line function, you're going to get the coefficient. And to differentiate 0.5q squared, you have to use the power function rule. So when you use the power function rule, you're going to end up getting q. Okay. And if you want to derive to the average revenue function, average revenue is total revenue divided by q. And as you can see just now, average revenue is the same thing as price. So when we talk about the function for average revenue, it's going to be exactly the same as your price function, which is 6.5 minus 0.5q. Okay. All right. Now, I have already mentioned to you that the total revenue function is a quadratic function. And for that reason, when you draw your total revenue function, it's going to, it's going to have a U-shaped function, but it's going to be a concave down shape. Okay. Now, your marginal revenue and average revenue curve both are straight line function. Okay, and because the slope are negative, so that's why it is downward sloping. Now notice that the marginal revenue function is steeper as compared to the average revenue function or price function. Okay, they are flatter. Okay, and in fact the slope of your marginal revenue function is twice the slope of your price function. So whenever you want to draw your marginal revenue function, make sure that it's going to be half of your price function. Okay, and your marginal revenue function also represent the slope of the total revenue function. So as you notice that, okay, when you move, okay, from 0 until the midpoint here, you can see that total revenue increase. Okay, so the slope is positive. So if you can see here, your marginal revenue curve along that quantity, okay, is positive. But after the maximum point, you can see that total revenue starts to decline. Okay, meaning that the slope is negative here. Okay, so this is represented by a negative value for marginal revenue. So your price curve, your marginal revenue curve, and your total revenue curve, they are all related. All right. Now, so far what we have done is I have already introduced to you what is a demand function. Okay, what are the factors that are influencing it, and how do we write a demand function, which can be represented in two forms, the linear function and the multiplicative function. As I mentioned to you, in this course, we're only going to deal with the line function. And just now we proceed by looking at how to derive to the demand curve function, conventional demand curve function, total revenue, margin revenue, and average revenue function. Now, why is it important for us to derive to all these functions? Now remember, going back to the first chapter, the objective of a firm, it varies. Okay, so some of the objective is to maximize profit, some of it is to maximize total revenue. Okay, so all this requires an understanding of the demand function. Okay, so what I'm going to do next is I'm going to show you some examples from the past year question in terms of how we apply the concepts that we learned today. Okay, now we're going to try sample questions, okay, taken from past year papers. This is actually applying the concepts, all the concepts that we have just learned, okay. So we have the demand. So before that, so this question is taken from June 2015, okay, June 2015, part A, question number 2. Okay, now we have a cafe named Maya Cafe. Okay, so the demand and total cost function is given as P equals to 410 minus 9.95Q, and total cost is 20 plus 10Q plus 0.05Q squared. Okay, now Q here represent quantity demanded, price of honey cupcake, P is price of honey cupcake, TC is actually the total cost. Okay, now you are requested to write, okay, the equation for total revenue, average revenue, and margin revenue based on the demand function given. Okay, so here the demand function that you have is the conventional demand curve function. Okay, so you have P equals to 410 minus 9.95Q. So the question is, how do we derive to these revenue functions? Okay, so okay, let me show you, okay, how are we going to do that. Okay, so you are given P, okay, equals to 410 just now. Okay, so P equals to 410, okay, minus 9.95Q. Okay, so this is your conventional demand curve function. So the question now is, how do you derive to the total revenue function? So remember that total revenue is your sales quantity. Okay, so it's price multiplied by quantity. And remember that we always write total revenue function in the form of Q's. So meaning that your price must be replaced with a price function. Okay, so your price function is already given by 410 minus 9.95Q. Okay, and so that's your P multiplied by Q. Okay, so what you need to do next is you simply cross multiply. So 410, you have to multiply it by Q. Okay. So 410 here, you have to multiply by Q. So that will give you 410Q. And then minus 9.95Q multiplied by Q, that will give you 9.95Q squared. Okay, so that's how you derive to the total revenue function. Okay, so very simple. So next we move on to average revenue. Now, average revenue, the formula is total revenue divided by Q. Now, you have already derived to the total revenue function. So, simply substitute that in. Okay, so your total revenue function is 410Q minus 9.95 Q squared. Okay, so you put that in and you have to divide everything by Q. So meaning that each of the component of total revenue, okay, you have to divide by Q. So 410Q, you divide by Q, that will give you 410 minus 9.95 Q squared, you divide by Q, that will give you 9.95 Q. Okay, and if you look at this function, it is exactly the same as your P function because we have already proven that average revenue and price is the same thing. So finally, we would like to derive to the marginal revenue function. So what's the formula for marginal revenue? You are required to differentiate total revenue with respect to Q. Okay, so if your total revenue function is 410Q minus 9.95 Q squared, so you need to differentiate it, okay, and you need to use combination of rules of differentiation. So 410Q, if you differentiate, okay, you're going to get 410, okay, minus, if you differentiate 9.95 Q squared, okay, so that will give you okay, so that will give you about 19.9, okay, 19.9 Q. Okay, so you need to bring down the exponent 2, okay, and then Q, and then reduce the exponent by 1 unit. Okay, so when you plug that into your calculator, you're going to get 19.9 Q. So your marginal revenue now is 410 minus 19.9 Q. Okay, now what's the next question? Okay, so let's look at the next question. So the next question wants you to find the price and output that will maximize total profit. So notice that your main aim is to maximize total profit. Okay, so to achieve this objective, what should be the price and output for your product? Okay, and to find this answer, okay, it's very essential for you to have your demand function apart from the total cost function. Okay, so now let us, okay, proceed with determining the price and output, okay, that maximize profit. So remember that your main objective is to maximize profit. Okay, so the question now is, what is price, okay, and what would be the level of output? So that's our problem now. Now, if you recall from the previous lecture, whenever you want to maximize or minimize something, that is optimization. And in calculus, okay, it requires you to differentiate, okay, the function and set equals to 0. So since you want to maximize profit, therefore you have to differentiate the profit function, okay, with respect to Q, and then you have to set it equals to 0. Okay, but before you can differentiate the profit function, you have to come up with the profit function because there is no profit function. So first of all, what we're going to do is we're going to derive to the profit function. Okay, so how do you calculate profit? Well, to calculate profit, it is simply total revenue minus total cost. Okay, that's how you calculate profit. But because you want a profit function, so all the component of profit must be in the form of a function. So total revenue you can represent with profit function. You can represent with the total revenue function, which you already derive it. So simply take the total revenue function. Okay, minus, now total cost function is already given, isn't it? So it's 20 plus 10Q, okay, plus 0.05 Q squared. Okay, so we have already substitute, okay, the total revenue function and the total cost function. So what's we gonna do next? So the next thing that you're gonna do, okay, so you are going to take out everything in the brackets. Okay, we're gonna remove the bracket. So 410Q minus 9.95 Q squared. Okay, so you already remove the bracket for total revenue. Okay, now when you want to remove the bracket for total cost, then you have to be a bit careful. Okay, don't forget that you need to multiply each of the component of total cost with the negative value here. Okay, so negative sign multiplied by 20, that will give you negative 20. Negative multiplied by positive 10Q, you're going to end up getting negative 10Q. And negative multiply positive 0.05 Q squared, that will give you negative 0.05 Q squared. Okay, so now we have successfully removed the bracket, okay, and you have taken into account the signs. Okay, now what do we need to do next? You have to simplify the equation further. Okay, so as you can see here, 410Q, okay, you can subtract it with 10Q, so that will give you 400Q. Okay, and then we have negative 9.95 Q squared minus 0.05 Q squared, so that will give you negative 10 Q squared. Okay, and then we only have 20 as a constant. Okay, so now you have successfully derived, okay, to the profit function, okay, which is 400Q minus 10Q squared minus 20. Now going back to our problem just now, now remember that Maya Cafe wants to maximize profit. The question is, what should be the price and output that it has to set? Okay, now we know that whenever you want to maximize something, you have to differentiate it and set it equals to 0. Now here your problem is you want to maximize profit. That requires you to differentiate profit function and set it equals to 0. Okay, now what's your profit function just now? So your profit function is this. So let's us differentiate it. Okay, so if you differentiate it, you're going to get 400 minus 20Q, and then if you differentiate constant, you're going to get 0, correct? Okay, and you set everything equals to 0. Okay, so what do we need to do next? Well, you need to rearrange this equation. Okay, so you need to bring the numbers to one side, the variables on the other side. So you have 400 equals to 20Q, or you can also write it as 20Q equals to 400. So if you want to find Q, what do you need to do? So you need to divide everything by 20. Okay, so you're going to end up getting 20. Okay, so that's going to be the value of Q. Okay, so if Maya Cafe wants to maximize profit, then it has to make sure that it produces 20 units of output. Okay, but we are not done yet. Okay, remember the question also wants you to find the price that can ensure maximum profit. So how do you find the price level? Now you are already given the price function, isn't it? So if you look at the price function, the unknown variable is Q. So therefore, if you want to know what is the price that maximize profit, you have to ensure that the Q here must be the one that maximize profit also. So let us write down our price function here. Okay, so that's our price function. So what you need to do is you need to substitute, okay, Q, okay, with the value of 20 just now. So 410 minus 9.95, where Q is equals to 20. So when you plug that in, okay, you're gonna get the value of price, okay, to be equals to 211. Okay, so if this firm wants to maximize profit, then it has to make sure that Q is 20 and price is 211. Okay, so can you see how we apply, okay, all this demand concept? Okay, so you started off with a demand function, okay, specifically it's a conventional demand curve function, and you are trying to solve a problem of this company where it wants, okay, to find out how best they can maximize profit. Okay, so to find profit maximization, so you need to utilize the conventional demand curve that you have already derived just now. Okay, but before that, make sure you come up with the profit function. Okay, you maximize it. Okay, and you're going to end up getting the optimal value for P and Q. Okay, now the final thing that you need to do, okay, for this question is that you are required to find the amount of the maximum profit. Okay, so what is the amount of total profit at the profit maximizing price? So in other words, you are required to find the value of maximum profit. So how are we going to do this? So you are already you have already derived to the profit function. That's your profit function. So you can see that, okay, the unknown variable in the profit function is actually your Q. So if you want to find the maximum value of profit, then you have to make sure that the value of Q must be the one that maximizes profit. And you have already found out that profit equals to 20, okay, sorry, quantity equals to 20 would be the one that maximizes profit. So you substitute that in, okay. So plug all this value into the calculator. So you're going to end up getting the value of profit equals to 3980. Okay, so this is, okay, the value of profit that you're going to get. All right. Okay. Well, there are several other questions, okay, that you can look at, okay, in the sets of past year questions, okay, relating to demand functions and how you utilize it to achieve or to solve problems faced by a firm. Okay, so there are various other equations that you can look at. Okay, so I hope that you can spend some time, okay, trying these questions so that you can get hold of the concept. Okay, all right. So let us now proceed to the next topic. Okay, so that would be the difference between the individual demand and market demand. Okay, now when we talk about market demand, okay, it refers to the aggregate of individual demand. In other words, is the total quantity demanded in the market. Okay, so if you're talking about functions, okay, so the market demand function would be the summation of the individual demand function. Okay, so in other words, if you want to derive to a market demand function, you're going to add up the individual demand curve functions. Okay, now let me illustrate this concept via an example. Okay, now we have 3 individuals, okay, and their demand functions for books is represented, okay, as Q1 equals to 30 minus P, Q2 equals to 22.5 minus 0.75P, and Q3 equals to 37.5 minus 1.25P. Okay, so we have 3 demand curve function, and each demand curve function is for 3 different individuals. Okay, now let's assume that there are only 3 individuals in the market, and you want to come up with the market demand function. So how are you going to do that? Now, based on the definition which I have represented just now, okay, to derive to the market demand function, you need to add up the quantity demanded from each individual buyers that you have in the market. So in other words, you need to add up Q1 plus Q2 plus Q3. Okay, so simply substitute each of the function. Okay, so Q1 just now was 30 minus P, and then you add it to Q2, which is 22.5 minus 0.75P plus 37.5 minus 1.25P, which is your Q3. Okay, so when you simplify all this equation, you're going to end up getting the market demand function as 90 minus 3P. So this is how you derive to the market demand function. Okay, so you need to add up the individual quantity demanded from each individual buyers. Okay, alright. And the next one would be determining market equilibrium price and quantity. Okay, so when we talk about the market, this is where, okay, we have a group of buyers and a group of sellers. They're gonna meet and they're gonna agreed upon one price and the level of quantity. Okay, so when we talk about market, okay, and if a market is in equilibrium, so what happens is that quantity demanded and quantity supplied should be equalized. Okay, and the price, okay, at this equilibrium point is known as the equilibrium price. Okay, so but whenever there is a change in demand or supply, or both demand and supply, definitely your market equilibrium point will also change. Okay, so the conditions for market equilibrium is that the price should equalize, or quantity demanded should equals to quantity supplied. Okay, now let us look at another example. Okay, so let's say you have quantity demanded represented by 10 minus PA, and quantity supplied equals to 2 plus PB. Okay, now if you want to find market equilibrium price and quantity, now remember, at the market, quantity supplied equals to quantity demanded. So what you need to do is you need to equate the two equations. Okay, QD equals to QS. Now, so QD just now is represented by 10 minus PA, and QS is represented by 2 plus PB. Alright, so now what we are trying to do is we want to determine market equilibrium price and quantity. Now remember that at equilibrium point, okay, quantity demanded will always be equals to quantity supplied. Okay, so now based on that condition, so we're gonna substitute, okay, the functions for demand and supply just now into this condition. Okay, so you can see that quantity demanded here is represented by 10 minus PA. Okay, so that's your function, and quantity supplied is 2 plus PB. Alright, now remember that at equilibrium point, okay, price will equalize. Okay, so let's say price will be equals to P. Okay, so you just replace PA and PB by P. Okay, and what you are doing here is you need to bring P to one side, okay, and figures to the other side. Okay, so so what happened is that, okay, when you bring P to the other side, you're going to have 2P's here. So that's how you got 2P. Okay, and the numbers here, you're going to bring it to the other side. So it will become negative. So you're going to end up getting 8. Okay, so when you simplify it further, you're going to get price equals to 4. Okay, so we know that at the market equilibrium point, okay, where quantity supplied equals to quantity demanded, or the supply curve and the demand curve intersect with one another, the price should be 4. Okay, now what about quantity demanded? Well, for quantity demanded, you simply substitute this P value here into either quantity demanded or quantity supplied function. Okay, because at the market equilibrium point, quantity demanded and quantity supplied, they are the same. So if you substitute in any one of the demand or supply function, you're going to end up getting the same values. Okay, so if let's say you want to substitute this P value into the Q into the demand function, so you're going to get 10 minus 4, okay, minus price, which is 4, so you're going to end up getting 6. Okay, now notice that if you substitute this value of price into the supply function, you're going to get to the same quantity. So your supply function here is 2 plus P, correct? So your P is 4, so 2 plus 4 is 6. So again, you're going to get to the same quantity demanded. So in a market, okay, always remember that supply, okay, so at the equilibrium point, supply will intersect demand, and at that point, quantity demanded will equals to quantity supplied. So whenever you want to determine the market equilibrium, okay, point, so you just use that condition, and all you need to have is the supply curve and the demand curve. Okay, all right. Okay, we can try one question. Actually, this is also taken from previous past year question. Okay, so we have, okay, so we're gonna try another example. Okay, so this time is to apply the concept on market demand. Okay, all right, so this is a question, okay, taken from December 2015. Okay, so we're going to look at question 2, okay, from part A. Okay, so let's look at the question together. So we have Amina, okay, has a company that produces t-shirts for charities. Okay, so her market consists of 2 groups. We have Ceria Orphanage and Jaya Orphanage. Okay, so their individual demand equations are as follows. Okay, so for Ceria Orphanage, it is P equals to 40 minus 2 QC, and for Jaya Orphanage, it's 55, okay, minus 1.25 QG. Okay, now the Q's here actually represents quantity demanded, okay, in hundreds, okay, and price is actually price, P is actually price per t-shirt, okay, in RM. Alright, now you don't need to worry the fact that Q actually represented in hundreds. Okay, so that is for interpretation purposes. Okay, but when it comes to calculation, you just take it as it is. Yeah. Alright, so let's look at the first question. Now the first question, okay, wants you to derive to the market demand curve equation for the company. Okay, so remember that, okay, from our definition, market demand is when you sum up the individual demand of the individual demand curve in the market. Okay, so when we want to derive to this market demand curve, okay, for the company, you need to add up, okay, the individual demand curve. All right, so how are we going to do that? Okay, so okay, just now, okay, you are given, okay, the Ceria demand function as P equals to 40 minus 2 QC. Alright, and the Jaya orphanage demand function is actually P equals to 55 minus 1.25 QT. Alright, okay, so as I said to you just now, our main aim is to derive to the market equation, okay, market demand equation. So by definition, okay, the market demand equation is the summation of the individual demand function. So that would be QC plus QG. Okay, but okay, if you look at the information given, so you only have information for price. Okay, so the equations that you have is in the form of a conventional demand curve function. But looking at the formula, okay, the formula wants you to add up the Q's, okay, and not the P's. So what are we going to do? So the thing is, you need to rearrange, okay, your P function so that now Q will be on the left hand side of the equation and P is going to be on the right hand side of the equation. So how are we going to do that? Okay, so let's start with Cherier's demand function. Okay, so that's the Cherier demand function. Okay, so what we're going to do is we're going to rearrange them. So we're going to bring negative 2 QC to the left hand side of the equation. So we already have 40 here, and P, when you bring it to the right hand side of the equation, it will become negative P. Okay, now so this one we're going to have 2 QC. Okay, alright, so now we're going to divide both sides by 2 because we only want QC here. So QC is going to be 20 minus 0.5 P. Okay, so now you already have your demand function for Cherier charity, but you can see that it is in the form of the demand curve function. Okay, it's no longer in the conventional form. So let us do the same thing, but this time around it's going to be for Jaya charity. Okay, so for Jaya, it's P equals to 55 minus 1.25 QJ. So remember, we want QJ to be the dependent variable and price to be the independent variable. So let's rearrange it. So negative 1.25 QJ, you bring it to the other side, it will become 1.25 QJ, okay, equals to, you already have 55 here. Now P, when you bring it to the right hand side, it will become negative P. Okay, so let's divide both sides by 1.25. So you're going to get QJ equals to 44 minus 0.8 QG. Okay, so all you need to do is you need to divide, okay, both sides by 1.25. Okay, so 1.25 QJ, you divide it by 1.25, you're going to end up with QJ. 55, you divided it by 1.25, you're going to get 44. And 1 divided by 1.25 will give you 44 minus 0.8 QJ. Okay, so now going back to the question. So what does the question want? So the question wants you to derive to the market demand curve function. Okay, so and it requires you to sum up, okay, the individual Q function. So where your QC is 20 minus 0.5 P, okay, plus QJ, where your QJ is actually 44 minus 0.8. Okay, so QJ here, okay, that was a mistake here. Okay, it's supposed to be P. So 0.8 P. Okay, so let's remove all the brackets. So you're going to have 20 minus 0.5 P plus 44 minus 0.8 P. Okay, so you're going to add up the numbers together. So that will give you 20 plus 44, that's 64, minus 0.5 plus 0.8, that's 1.3p. Okay, so QM equals to 64 minus 1.3p, that's your market demand. Okay, now let's look at what's the next question. Well, the next question here says, so the next questions here, if Amina charges 30 ringgit per t-shirt, what is the quantity demanded by each group and by the market? Okay, so now you are told that price is 30 ringgit. Okay, so price is equals to 30. So the question is, how much is QC? Okay, how much is QJ? And finally, how much is the market demand? Okay, so whenever you read this question, you need to understand and try to figure out what does the question want. And it would be beneficial if you can write the main point or the main thing of the question. Okay, so you are given price equals to 30, you are required to find QC. Now your QC function, you already got it, so that's 20 minus 0.5p. Okay, so now what you're going to do is you're going to substitute p, okay, with 30. So plug all this value into the calculator. So what are you going to get? So you're going to get 5. So that means at price equals to 30, Ceria will demand 5 units. Now what about QJ? Now QJ function just now, okay, was 44 minus 0.8p. Okay, so you want to find out what would be the quantity demanded when price equals to 30. So simply plug that in. So P being 30, and then you key in all this information into the calculator. That will give you 20. And finally, the market demand. Okay, so the market demand function, you have already derived it to be 64 minus 1.3p. Okay, so this is your market demand function, and you are asked to figure out what would be the value when price equals to 30. Okay, so plug these values into the calculator and you're going to end up getting 25 units. Now notice that, okay, the value of the market demand is it tallies with the total of the individual demand. So notice that in the market you have demand from Ceria and Jaya. So at price equals to 30, Ceria demands 5, Jaya demands 20, and when you add up the two, the market demand is 25. And this answer actually tallies with the value that you get from the market demand function just now. So when you substitute P equals to 30 into the market demand function, you're going to end up getting 25 also. Okay, so for today, okay, what we have done, okay, so far is looking at demand. Okay, what is the law of demand? What are the factors that influencing it? Okay, you have also been introduced with the demand function. Okay, so remember that the long function is what we call as the demand function. Okay, but looking at the demand function, all the factors that influencing it, some of it you don't have control, while some of it you have some control. Okay, so whenever you want, okay, to analyze the demand for your company, you always want to focus on price. So that brings us to the demand curve function. Okay, so I have already shown you how from the long demand function you're gonna reduce it into demand curve function, conventional demand curve function. Okay, and using the conventional demand curve function or the P function just now, we have also learned how to derive to total revenue function, average revenue function, and margin revenue function. And as you can see, okay, all this function is very essential for you to answer the problems faced by an organization. So we have already looked at some examples where we have companies that wants to achieve a maximum profit. Okay, so to do that, okay, they require to know, or they are required to know about the demand function, because without the demand function you cannot derive to the profit function. Okay, so this shows that demand is very important. Okay, I have also introduce you to the concept of individual demand and market demand. So remember that individual demand is demand from individual customers, but market demand would be the total demand from everybody in the markets. Okay, and finally, to determine market equilibrium, remember that in a market, this is where the suppliers and the buyers, they will meet and discuss on the price. So the price that they agreed upon is what we call as the market equilibrium price. So at this market equilibrium point, quantity supplied and quantity demanded will always equalize. Okay, so I want you to look through again at all this concept, okay, because this is the basis, okay, for the market structure chapters. Okay, so it's very important for you to know about demand. Try some of the questions on demand and how you derive to the respective demand curve functions, total revenue function, and also profit function. You also need to know how we can optimize how this function to solve problems in an organization. Okay, so in the next lecture we're going to concentrate on the concept of elasticities of demand. So these concepts are very useful, okay, for managers, okay, to understand their customers better. Okay, so we're going to look at price elasticity of demand, income elasticity of demand, cross elasticity of demand, and finally advertising elasticity of demand. Okay, so for the next lecture we're going to look at these 4 different concepts of elasticity. So with that, okay, that's it for today. Thank you.